Okay. So next is number 3. Consider another system similar to that in 2B. Okay, this one. With a linear spring that is attached to the piston. So the system has the same initial condition as in the question above and undergoes exactly the same process. The spring has the spring constant of 150 kN per meter and the cross-sectional area of the piston is 0.25 meter cube. Okay, so we have additional offspring here, and the cross-sectional of the piston is A equals to 0.25 meter cube, and we have K equals to 150 kilonewton per meter. The area is square. Yeah. Okay. So how to make a start? So it means initially P1 300 kilopascal, but when you have spring loaded piston here, spring here, so when it expands, okay, so V2 equals to for V1. So we have additional of pressure. We have P1 plus additional of pressure here because we have spring. So how to solve this? Okay. So we have for spring loaded, we have K equals to 150 kilonewton per meter. And we have A equals to 0.25 meter square. Okay, we have equation of F equals to Kx. Okay, so to get F equals to Kx, to get P, pressure, equals to F over A. So in order to get P, pressure, okay, we need to get F. So how to get F? You need to get Kx. But you need to get X first. So what do we have? What is the equation for X? X equals to delta V over A. Okay, so we'll start with that. X equals to delta V, which we have calculated just now. Okay, delta V over A equals to 0.1365 meter cube, A 0.25 meter square, equals to 0.546 meter for X. Therefore, F equals to Kx equals to 150 kilonewton per meter. X 0.546 equals to 81.9 kilonewton. And P equals to F over A equals to F equals to 81.9 kilonewton. A equals to 0.25 meter square. Okay, you will get 327.6 kilopascal. Okay, with additional spring loaded, okay, still from 1 to 2, remember. So initially we have P1 equals to 300 kilopascal, but with additional of spring, yeah. So we have extra pressure, which this is P spring, which we have calculated here. So P1 300 kilopascal plus 327.6 kilopascal. Okay, the total pressure of initial and this is the P2. Okay, therefore, okay, so P2 is actually equals to P1 plus P extra from spring loaded. So we will get 300 kilopascal initially plus 327.6 from spring, okay, equals to 627.6 kilopascal. Okay, what is the question anyway? Okay, calculate the boundary work done by the system. Okay, work of boundary equation, since we have different pressure, okay, pressure 1, pressure 2, and volume is also changes, okay, so basically it is PdV, but we have different pressure, we have different volume, so it's kind of we have different pressure and we have different, okay, so if this is P, this is V, it means we have P1, P2, okay, so we also have V1 here, V2 here, okay, so we have different value of P1, P2, nothing is constant, therefore it is equals to area of trapezium. Okay, so the equation of trapezium is equals to, okay, P1 plus P2 over 2 V2 minus V1. Okay, so P1 is 300 plus P2 627.6 over 2, and V2 minus V1 is the delta V. Okay, this is your delta V. Yeah, this one. Okay, 0.1365, which is equals to 85.66 kilojoule. Okay, have we answered the question? Calculate the boundary work done by the system. Okay, that's all.